All fine. So today, of course, we are going to continue what we stopped at. Of course, we solved yesterday 26, what our last thing we worked on, and now we are going to problem 27. So, first of all, let's read the question. In each of the squares, a number should be written so that the sums of the four numbers in each row and in each column are the same. What number goes into the shaded square? So, of course, we are working on this square. Each row and each column, the sum of each digit will be the same. Of course, we have a lot of empty spaces, so we don't know how much this column will be or this row will be. By the way, these are the hardest questions, so we need to focus and we are going to try to solve them even in the exam. So you are going to find a way so you can solve it quickly. First of all, let's do it together. For me, whenever I'm dealing with this situation, I don't have enough numbers. I'm going to find the boundaries. So, of course, the shaded number, I'm going to predict it. We can't find it directly. So, of course, the value we're going to find now will be bounded between two values. So, I need to find the sum. It's supposed to, each row and each column will have the same sum. So of course the sum will be bounded between two values. So we can predict or try the values. So we can predict which one will be the best one or the answer. Now, first of all, it's clear for us. Let's start with the rows. First row, 1, 6, 3, and here we're going to find a digit between 1 and 9. Just remember, all of them have the value between 1 and 9. So, of course, the maximum, I'm going to start with the maximum, will be 9. Suppose it's 9. 9 plus 1 is 10, plus 6 plus 3 is 19. And everything can be changed. Always remember that. The minimum, 1, I'm going to put 1 here. So 1 plus 1, 2, plus 6, 8, plus 3, 11. So this is my minimum. Now let's move on. So we can maybe the sum of a row or a column must be bounded between 11 and 19. So it can be 11, 12, 13, 14 till 19. Let's make it smaller. So of course we're going to try different one. I have this row, I have 12. I'm going to try it if I added 1, so it will be 13. The minimum is 13 for this row. This row must be equal to this, so of course we can change 11 to 13. I'm not going to change it now. I will write all the values and then we can do our change. Now, if it's 9, 9 plus 8, 17, plus 2, 19, plus 2, 21. So, of course, in the up, we're going to stick on the smallest one. Here we can find because we have two numbers only. Okay, but in case if we want to find the minimum, of course, 1 and 1. They didn't mention anything about repeating numbers, so of course we can put two numbers, and we can see that clear here. Concerning the 2 in the second row, I have 2 and 2, so we can repeat the numbers. So if we added 1 and 1, we will be left with 9 plus 4, 13, the same as here. The maximum 9 plus 9, 18, plus 7, 25, plus 4, 29. So it's more bigger than it, so I don't care about it. And for this one, of course, we're not going to find it. Maybe we're going to start with the columns. I have 3 and 4, 12, plus 3, 15. plus 1, 16. So the minimum can be equal to 16. The maximum 9 plus 8, 17, plus 3, 20, plus 4, 24. So of course, choose the smallest big number. So it's bounded from above. We're going to stick on the smallest one, so it's 19. I'm going to erase all the other possibilities and I'm going to stick on 19. Now, I'm going to choose the biggest, smallest number. So of course, any number smaller than us, I need the bigger one so we can make our domain small. It's 16. So of course, we can write 16 up. So the thing I want to tell you now, 16 and 19 we are dealing with. Maybe 16, maybe 17, maybe 18, maybe 19. So of course we are left with 4 choices we can test. Now we can test because otherwise you will test a lot of numbers. Now we have only 4 choices to test. So I have 5, I have 6, 7, 8, 9. It can be here. I'm going to start my testing before I get the number with 16. Let's start from 16. I'm going to write it so we will never forget about it. So in order this column to be equal to 16, I have a plus 4, 12, plus 3, 15. I need 1 here. In order this column to be equal to 16, I have 13 and 2, 15. I need 1 to obtain 16. So we are only going to try. Maybe something will get wrong concerning the rows. 2 plus 7. Now this one will be hard, so I'm going into this row because I have only 1 unit missing here. So 1 plus 6 plus 3, 10. In order to get 16, we need 6. So 6 plus 7, 13, plus 2, 15. I need 1 to get 16. Okay, so concerning the columns, everything is right. Concerning the row, this one is wrong, is right. I'm going to check this one. 12, 11, sorry, 8 plus 2, 10, plus 2, 12. I need 4 to get 16. Until now, we are fine. Let's try these two. 7 plus 1, 8, plus 4, 12. I need also 4. Okay, so concerning this row, 7, 8, 9. In order to get 16, I need 7. Now we're going to check it for this column. If it's right, then this is our answer. If it's wrong, then we are going to try 17 and we will cross 16. Let me check. 4 plus 4 equals to 8, plus 7 equals to 15, plus 1, 16. So the property works on this choice. I started with 16, the sum is equal to 16, and it's right. If not, then I must go to 17. Also, if it's not, I have 18 and I have 19. Okay, so this is the right answer. This is the right puzzle. And of course, we're going to stick on 7. Yes, it's C. This is how we found C. Now, let's move on. Before I want to make a small summary about it. So first of all, we found the boundaries for the sum, the maximum value and the minimum value for the sum. So we started first with 11 and we found 16, the least value it can take. Maybe in this columns it was 16, so we took 16, the highest one, and 19, the smallest one, and of course the S must be equal to 16, 17, 18, or 19. S is equal to the sum of digits in one row or one column. All of them are equal. Now, we started trying from 16. So if the sum is equal to 16, what are the numbers missing? We wrote everything. We checked. Yes, it's okay for all rows and all columns. Then we are fine. If we had some small mistake here, of course, we are going to move to 17. We are going to try different values. So the unknown, we started with as the sum, and then we found the shaded square. Okay, I'm going to write the shaded here. So the first thing I found the sum, the second is the shade. The sum was equal to 16, 17, 18, and 19. So we must try all of them, and then we are going into the shaded square. So we found in 16 is equal to 7. It's okay for all the rows and all columns. We checked that, and then we choose the number 7. This is the right answer. Now, for number 28, I'm going to skip it now at the end if we have time, because I made a small trick here, so I'm going to explain it, but it's not accurate 100%, so I'm going to skip it now. I'm going to the direct exercises. So, for example, this one. A zigzag line starts at the point A at one end of the diameter AB. So, of course, it's a semicircle. It's not a circle. Now we are dealing with semicircle, but the same rules applies for a circle. Please don't forget that we are going to use rules we already took in circle. Each of the angles between the zigzag line and the diameter AB is equal to alpha, as shown. After 4 peaks, the zigzag line ends at the point B. What is the size of the angle alpha? So we need to find the measure of the angle, this angle or this alpha. Now, first of all, whenever we are dealing with such problems, continue drawing the shape, and of course this angle will be alpha, this angle will be alpha, and this angle will be alpha. Now this one is a hard question, so we are going to move step by step. Okay, first of all, I have alpha and alpha. So two angles are equal. First of all, I will think about the isosceles triangle. But what are the properties do I have in isosceles triangles that may help me in finding this angle? I have nothing. So of course, I will skip this step. So no need for understanding that this side is equal to this side. It doesn't matter. So I can't find the value of alpha using this property. So I'm going to search for another one. So of course, first of all, whenever you are dealing with an arc or a circle in general, but now I'm talking specifically on arc. We all know that the arc is equal to the angle, this angle facing the arc, and this angle starts on the diameter, right? So of course, I'm going simply to find this angle. First of all, maybe we will find a relation here. So this angle is equal, look, 3 angles makes the straight line. So Three of them, let me call it, for example, theta. So simple mathematics, alpha plus alpha plus theta equals to 180 degrees. Okay, so it's clear for us. This is nothing I didn't create anything concerning it. We just gave a name for this angle so we can use what we know. Okay, alpha plus alpha to alpha and plus theta. So of course I'm going to subtract 2 alpha from both sides so we can find the measure of theta alone. So of course theta will be equal to 180 minus 2 alpha. Usually we put them all in parentheses and up we're going to write the degree, but now we are talking about the measure. Okay, I will skip that because we don't have time to waste in these problems, so directly we're going to solve. Now if this measure of this angle is equal to this value, I need to compare it. So this one is equal to this arc. We all know that. This angle also will be equal to theta. So it's equal to this arc. And this angle will be equal to theta. Also this arc. Now I have 3 arcs, but I don't have the value of the arcs. So simply what are we going to do? Now let's focus. We have this one and this one. Okay, as you can see, we have a chord here and a line here. I know that these two lines are equal. So of course there is a property. Now we are going directly to apply it. That this arc is equal also to these arcs. And then finally I'm going to say simply that if this arc is equal to theta, and this arc is equal to theta, and this arc is equal to theta, so 5 theta is equal to what? All of them are equal to 180. So theta alone will be equal 180 over 5. I'm not going to replace it now. Let's deal with that as a fraction. Don't solve it now because we still have steps to obey. Okay. Now, the question was not how much is theta. The question is how much is alpha. So of course we're going to relate it direct to this one. So I have two values for theta. Of course they must be equal to each other. So let's do it down. 180 minus 2 alpha equals 180 over 5. So I'm going to write down what I'm going to solve. And of course, you can use your calculator now to find this, the 180 over 5. Okay, so simply we are going to say that 180 minus 2 alpha is equal to 180 divided by 5, which is 36. So first of all, I don't like solving linear equation with a negative sign on the unknown. So I'm going to add the 2 alpha on both sides. So of course, these two will disappear. I will be dealing, let me switch them, 2 alpha plus 36 is equal to 180. I did nothing here, guys. I only switched the sides. So of course, now we are going to subtract them with 36. I have that 2 alpha. These two terms will go on together, equal to 180 minus 36, which is 144. And of course, at the end, I'm going to change the color to blue. I need to divide with 2 to get rid of this coefficient. Okay, so I need my answer to be alpha, not 2 alpha. I don't care about 2 alpha. So alpha directly is equal to 144 divided with 2 is, let me try it, 72. By the way, it's clear for us because 4 divided by 2 is equal to 2 and 14 divided by 2 is equal to 7. So another answer, no, I have this one, B, to be the right answer. I'm going to repeat it. From the figure, it looks like hard question, but of course it's not, it's an easy one. So simply I found that these angles are equal to alpha. Of course, this angle is also equal to alpha. Please, I need you all to know that, because 3 angles in a triangle also make 180 degrees. So the sum of 3 angles of the 3 angles in a triangle is equal to 180, and the sum of angles forming a straight line also 180. So these are the same. Now we simply did the following. First of all, theta is equal to the arc facing it because theta is on the diameter. Okay, if it's not on the diameter, then we are facing different situations. Maybe outside the circle, maybe inside, over 2, multiplied by 2. Now I care about this one. When it's on the diameter, then alpha is equal to the arc facing it. And we counted the arcs. We have 5 arcs, so 5 of theta will form 180. So of course, we found here the answer was 36. So it's equal to 36. Of course, it's not our answer because we are not done yet. We already just found the value of theta. And we need also the relation between theta and alpha. We have one here. Of course, alpha plus theta equals 180. So theta will be equal to what? Let's solve it for theta because I have theta here. Theta is equal to 180 minus 2 alpha. And of course, we compare two equalities. So 36 will be equal to 180 minus 2 alpha. And we solved this linear equation for alpha. So finally, we got the value of alpha, which is answer B. Okay, hope all of you will get the idea of this. And now the hard one. Telling you it's a hard one because there's a lot to do in this exercise. Of course, it is the last one. That's why it took us the most time. It will take us the most time. So, 8 consecutive 3-digit positive integers have the following property. Now, as you can see, I have 8 consecutive integers. So, of course, we will deal with the number from 1 till 9 here, and 1 till 9 here, and 1 till 9 here. Each of them is divisible by its last digit. So, of course, the whole number will be divisible by the last digit, and they are consecutive. So, you have just to add one to get the other one. So if we can get one of them, we are fine. We can get all of them. Now, what is the sum of the digits of the smallest of the 8 integers? So here the game begins. All of you just focus on this idea. If the whole number should be divided with the first number, I need the sum of the sum of digits of the smallest number among them. So I'm going to deal with 8 numbers. The first one, the second one, the third, the fourth, and the fifth, and the sixth number, the seventh, and of course the eighth number to obtain 8 different numbers. We are dealing with 3 digits number. So of course we're going to start with 100 until 999. So I'm pretty sure we are not going to try all the numbers. We are facing now like 900 numbers. So no, of course we are not going to try 900 numbers. We don't have enough time for that. We need like a week to try them. No, just focus on the idea that the whole number is divisible by the first one. We are dealing with 8 consecutive numbers, so it can start with 1, it can start with 2, 3, 4, 5, 6, 7, and 8. But also, I know that 9 is the digit, so of course, it can start, we are going to write it opposite. So 9, 8, 7, 6, 5, 4, 3, and 2. Okay, so in this choice, there is no 1. Let me start with the first one. Okay, so these two numbers will be fixed, of course. Only the digit will change. So from 1 to 2, 3, 4, or from 2 to 3, 4. Okay, so these two numbers will be fixed. I'm going to start with this one, this choice. Okay, so fix these. Of course, there's chance they will never be fixed if the smallest one was like 259. The consecutive to it is 260. So it's different. Now we are only going to start to work on these two choices, because if this was the problem, then we're not going to have a solution for it. Now I have two choices. I'm going to start with the first one. So let's suppose that starts with 1. Or if you want, we can delete it and then we can extend our square. So 1, 2, and of course the 3, etc. I'm going to do the same for all numbers. Now, we know that each of them is divisible by its last digit. So, of course, all of this number is divisible by 1. Any positive number is divisible by 9. So, I have 99 choices to test here. I'm going to skip this one. Numbers here are going to be divisible with 2. So any number starting with 2 will be divisible by 2. So I have 99 choices also. So I'm going to ignore it. And 3. Okay, the sum of digits must be divisible with 3. So maybe this one will help me. The 4. The first two numbers, two integers, must be divisible with 4. So also this one we're going to use. The 5. The first number should be divisible with 5, but we are starting with 5, so it's obvious that we can divide it by 5. 6. We need a number divisible with 2 and 3. So yes, maybe we can use it later. 7 and 8. I'm going to start with 8 now. If we are dealing with a big number, like a number consisting of 5 digits, or it's 1,000, if the first 3 numbers are divisible with 8, so the rest of the number is divisible with 8. I don't care about it. So, of course, we are dealing only with a 3 digits number, so we're not going to use it at all because we have the property already. Let's work on 7. Usually in this kind of problems, I start with 7 directly because all of the game is here. So, in order to check if the number is divisible with 7, we need to take the first digit, multiply it by 2, and then subtract it from these two numbers. So not only 2, maybe I'm dealing with a 5 digits number, so for the rest of the numbers. So of course, now I have these two. These two, we're going to subtract the result here from them, and then if this result after subtraction is divisible by 7, then all of the number is divisible by 7. Okay, let me write divisible by 7 because we are going to use it. We are going to use it a lot. Okay, so for me, to be honest, for now, it's obvious for us that we found the key of the solution. We didn't do all the work, but we found the key where to start. So the real question is, what are the numbers? Let's do it opposite direction. So I don't have the numbers to start and test. I need to predict which numbers can be divided by 7 with the remainder 0. So, or in other words, divisible by 7. I'm going to start with number ending with 7. Fix it. And I have 2 digits, so I can move on. We're going to multiply it by 2. So 7 multiplied by 2 is 14. And then we are going to subtract 14 from these 2 digits. So of course, if they were, for example, 99 minus 14, it's 85. 85 is not divisible by 7 because remainder will be equal to 1. So it's not my choice. Are we going to use it from 1 till 99? Of course not. Or from 10 till 99, because this one cannot be equal to 0. If it's equal to 0, then this number is not a 3-digit number. It's only a 2-digit number. Now, of course, we are not going to try all the possibilities. We're going to find the possibilities. How to find them? Okay, so I need a 9. When we take from it 14, it will be divisible by 7. Now simply, when I have numbers between 0 and 100, I need to test which are divisible by 7. Of course, we are going to try to write the multiples of 7 directly. So yes, I did change the color, so it will be clear. 7 times 1 is 7. Of course, the 0 is included, but we don't need it. And 7 plus times 2 is equal to 14. Now simply you can add 7 to each one instead of multiplying. So it's equal to 21, 28, 35, 42, 49, 56, 7 times 8, and then 63, and then 70. Of course, you all know that it's times 10. 77 times 11, and then 84, and then 91, and the final one, 98. Now, we need to subtract 14 from it and check if it's divisible by 7. The multiples, of course, look at 7, for example. If we took 14 from it, then we're going to get negative 7. No, it's not our choice, so we can simply take it off. 14 minus 14, it's 7. It's 0, which is divisible by 7. Of course, any number is divisible by 7. Let's keep it now. I don't want it, but let's keep it because it's obey our condition. Till 98. Now, we're going simply to start testing each one. First of all, the minimum in my case will be 1. So I'm going to start with 1, for example. 141. Add the digits, we're going to get 6, which is not included. If we stick on the other one, 14 plus 2 is equal to 7. So also it's not included. Yes, we can remove it now. Here, 211. Of course, 4 is not included, so we're going to take it. But first, try it for 2. Yes, 5. No need for it. 28 1, 11 included. So let's keep it now. 3, 5, 1, it's 9. So we can take it off, but in this case, the lower one will be 2. So of course 12 is included, so let's keep it. 2, it's 10. Sorry, not 12. Let's keep it. 4, 2, 1, of course, 7 not included, and 8 also not included. Take it directly off. This one, 13, and we're going to add 1, 14, it's included. This one, 11, 12, it's included. 10, 11 included. 7 plus 1 or 7 plus 2 is not included, so take it off. 7 plus 7 equals to 14, the maximum, so when we add 1 or 2, we will be out of the range, so let's take it out. 8 plus 4 is equal to 12, plus 1, 13, plus 2, 14, so let's keep it. And this one, 9 plus 1 in range. This one, of course, it's up because 9 plus 8 alone is equal to 17. And adding a positive number to it, of course, we will be out of the range. So now we are left with 1, 2, 3, 4, 5, 6, 7 numbers. Yes, of course, we can try. But before moving on, remember the conditions. So, of course, when the number, I'm talking about 4 here, 9 here, 7 here, for example. So, it should be divided with 7. Now we tested that. We found these numbers are okay, are fine with 7. So now we are done with 7. If you want, we can try them with 8. But it will be a big one. Let's do it. So I'm going to teach you how to test that on your calculator. So now simply write in front each number 8, and the number must be divisible with 8. Okay, so now we're going to open the calculators. 288, the first number. We're going to divide it with 8. I have 36, so I'm fine with this number. The other one, 358 divided with 8. No, it's a decimal, so directly I'm going to cross it out. I crossed this one. I need to try this one now. 498 divided with 8, 62.25, so it's a decimal, so it's not divisible with 8. Now, 568 equals to 71, so I'm fine with that. 638 decimal, so I can cross it out. Now, 848 divided with 8, 106. So it's a whole number, I can keep it. And the last one, 918 is equal to, no, 114.75. So also I'm going to cross it out. So 1, 2, 3 choices left. It's easy one. We have only 3 choices. We can test with another one. We already did 9. No, 8, sorry. We did that for 8. Now if you want, you can test it for 6. For 5, it's obvious. Any number starting with 5, of course, it's divisible with 5. And for 2, for 1, obvious. So we're going to try 3, 4, 6. Okay, let's do it. 4, if you want, the 4 is easy one. Now let's take off the 8, and I'm going to change the color. And write instead 4. So I'm dealing with 284, 564, and 844. Okay, so let's start from the beginning. 84. 284, we need only the first 2 digits. We're going to try that number. If it's divisible by 4, then we are fine. 84 clearly is divisible by 4 because 4 multiplied with 10 is 40. Another 10. We're going to get 80 and 4, so 21. Yes, we will keep it. 64, also it's divisible by 4. Now this one, maybe we can remove it. No, 44. 44 divided by 4 is equal to 11. So we need them, the 3 of them obey the rules for 4. We tried that, so I'm going to throw X for it. Let's try 6. 6 is a hard one. The number must be divisible by 2 and divisible by 3. Obvious, the number will be divisible by 2 because 6 will always, we're going to start with 6, so 6 is an even number. It can be divided by 2, so I'm going to skip it if you want because it's only the conditions of 3, and here we have the conditions of 3, so there's nothing left to test except of 3. You can replace it with 6, you can replace it with 3, it's fine. Now let's write down our last experiment. So 3, 3, and 3. Okay, so if a number is divisible by 3, of course the sum of digits will be also divisible by 3. So 283, I'm going to add the digits, I'm going to get 13, but 13 is not divisible by 3, so directly remove it. I'm only left with 2 choices now. It's great work. Now 5 plus 6 is equal to 11 plus 3 is equal to 14. No, it will never be divisible by 3. The last one, 8 plus 4 is equal to 12. Let me double check. It must be my right answer, but I'm double checking it because maybe we did something wrong. 8 plus 4 is equal to 12 plus 3 equal to 15. 15, yes, is divisible by 3. If we divided 15 by 3, we'll get 5. So, of course, this one, the only one left. So, my answer will be only replace the values. So, 8, 4, 1, 8, 4, 2, 8, 4, 3, etc. till I reach the last one, which is 8, 4, 8. So this is the set of consecutive numbers we need to find. Now let's go back to our question. What is the sum of the digits of the smallest of the 8 integers? So the smallest one, of course, will be the first one. The sum of digits, we're going to add 8 plus 4 is equal to 12 plus 1 is equal to 13. So D will be my choice. Okay, so I'm going to repeat it fast. before I'm going to move on to the last one, we are going back to the last one. The thing we did here is the following. So we need to find a number that's divisible by the first digit, and we need 8 consecutive of them. Each one is formed from 3 digits and divisible by the last digits. They need the sum. Okay, never mind about the sum now. So we need to start either with 1. We found that we finished at 8, so of course we have another choice, but we didn't use this choice because the right answer was here. So in this case, from 9 back to 2. So of course, once we are going to start with 1. If this one was not fine with us, we're going to start with 2. It doesn't matter now. First of all, we started with 1. So I have 2 numbers and 2 digits, and the third one should be starting from 1. In order to let them consecutive, we're going to add 1, 1, 1 to each number. So how many chances do I have? I have 99 chances, and of course it's bigger than 10, smaller than 99, so I have 98, 89 chances. I'm not going to test that. As I told you, we started with 7 because 7 months have the most complicated condition that we can use to find a little bit of chances. Now, I told you that 7, a number to check if it's divisible by 7 or not. I'm going to add, to multiply by 2 the first number, which is 7 in this case, and the result will be equal to 14. And I'm going to subtract this number, these 2 digits number, with 14, and I'm going to check if it's divisible by 7. So of course I wrote down the multiples of 7 from 7 till the last. I need multiples under 100 because 2 digits only. I don't need 3 digits. And of course, if we subtracted 14 from 14 equals to 0, but from 7 it's negative, so we crossed out this solution. Now we are left only with 14 till 98. All of them are divisible with 7, so we're going to keep them. Then we went for our choices. We crossed out according to our choices. So in which properties we can't get a sum in this range between 10 and 14. We crossed out and we are left only with few results. So you can do that at the end, doesn't matter. But at the end, I guess we're going to be left with 2 numbers according to this property. But in this range, we have only one number, which is 840 something. So first of all, we tried the numbers divisible with 8. So the numbers that are not divisible with 8, we can cross them out. The numbers divisible with 5 are obvious for us because any number starting with 5 is divisible with 5, and 2 the same thing. 6 divisible with 2 and 3. So of course any number starting with 6 must be divisible by 2. I don't need that choice. I'm going to test only the 3 at the end. So we tested which numbers are divisible with 3. We were left only with 3 choices. We tested them. The first one was crossed, the second crossed, and the third was accepted. So the reason why we took this one is because this one is the accepted one, the only one obeying the law. So first of all, they want the sum of digits of the smallest number. Okay, so simply the smallest one, of course, we're going to start with 1 because we have 8 different integers. All of them are consecutive. So a plus 4 is equal to 12 plus 1 equal to 13. That's the reason why we stick on this choice. Now, I need to solve, yes. Okay, sorry, I was preparing it. Okay, as you can see, even when I solve alone, I use the method of crossing out the unsuitable answers. Now, the last one in this session and also on this template is the following 28. Amal, Basma, and Sahar had a table tennis contest. Okay, in each game, two girls played while the third rested. Of course, we need only two players. After each game, the winner played the next game against the girl who had rested. In total, Amal played 10 times. So these are for Amal, Basma 15, and Sahar 17. Who lost the second game? Okay, strange question. Very strange question, but I'm going to tell you why we took the right answer. So first of all, I will think as follow. If Amal played 10 times, let's write the symbols. Amal, we are going to denote it with A. How many times? 10. Basma would be. How many times? 15 times she played. Sahar, 17. Sahar is S, starting with S, 17 times. Now we're going to avoid the names. We're working only with the letters. Let us start with, first of all, how many games they played. I don't know the answer, but we must find it out. If each one played and each game contains only two players, so I'm going to add the sum of them, how many times each player played, and of course I'm going to divide with the number of players, which is 2. So simply number of games, let's denote it with N, is equal to 17 plus 10, 27, plus 10, 37, plus 5, 42. Over the number of players, so clear for us, 1, 2, so it's 21. So I have 21 games. Let's divide them with a different color, of course. I have 21 games. I have Sahar with the most number of games. So this one is Sahar. She played with, of course, she will play with one of them. So one time with Amal and the other time with Basma. How many times? 17 times we saw this game. And I have that. Also on the other side, I have Sahar lost. How many times? The left. So I have 4 games. Sahar was not in them. So of course, A and B played together for 4 games. Now, if we want to go deeper here, we can find how many games between S and A. So simply subtract them. A played 10 games, 4 with B, so of course this number will be 6, 10 minus 4. And B played 15 times, 4 of them with A, so of course 15 minus 4, 11. So between S and B we have 11 games, between S and A we have 6 games, and between A and B we have 4 games. Now, what we are going to do is the following. First of all, if first of all, to be honest, we don't have a direct method to find the right answer, but we're going to cross out. So if S and A, if S played 17 games, she lost only 4 games. I'm going to divide 21 with 4. I'm left with 5 point something. So of course, she's going to start. She's going to win for 5 consecutive games until she will lose 1 game, and then she will go back, of course. So this is why Sahar will never lose. Oh, I have 5 choices, so either Basma or Sahar. No, I can remove it also. I'm left with 3 choices. So of course, at 33.34% to be right if we choose anyone. Now, Amal, Basma, and the last one is either Amal or Basma. So if I want to say that in the next game, Basma lost, let me be honest with you. So I'm going to fix S first. And of course, she will play with A. And then we have S and B. And if B lost, I'm going to go back to A. So 3 games out of 21 games, I found A twice, but A played only 10 times. So I'm going to divide it from here. So the ratio of it is 21 games. She will play 10 of them, 11 of them she will be outside. So of course, number outside games must be bigger than the games she shared. So of course, this one will be rejected. So for me, Basma will never lose the next game because she's not in it. So I will take off Basma, and of course I will take this choice because I don't want Basma to be there in the second game. And I will stick on A. Okay, so this is why I chose A. If you have time, you can try all different ways, so you can double check your work, but you will never have enough time to try all of these 21 possibilities, and you're going to switch them. Okay, so next time we will start with the latest one, and we are going to solve it exercise. Thank you all, and please, anyone who got questions, please directly send me a message. Thank you all.